Hi, I'm John Barba, and welcome to TACO's FlowPro University online presentation of the anatomy of a circulator. In this program, we'll talk about the difference between a pump and a circulator, how a circulator works, and specifically what it does in a hydronic system, the different types of circulators, the parts of a circulator, and how each one affects the circulator's performance, plus how to read a pump performance curve and use that information to choose the best circulator for whatever type of job you're working on. So first, let's ask the obvious question. Why should we care about a circulator or the details of how a particular circulator is designed and manufactured? Well, that's an easy one. The circulator is the vital heart of any hydronic system. You really can't make a hydronic system work without a circulator. Something has to make the water go round and round. And the circulator has that one purpose, and it has that one purpose only. It's to circulate the water in the system by creating flow. It creates flow by using centrifugal force to create a pressure differential. That's why sometimes you'll hear people call circulators centrifugal pumps. Now, before we go any further, let's clear up a very common misunderstanding. We all tend to talk about pumps and circulators as if they're the same thing, but technically they really aren't. A circulator doesn't lift water the way a well pump lifts water. It circulates water through a continuous loop system by creating a pressure differential. Water enters the circulator at a lower pressure. The circulator then accelerates the water and sends it back out at a higher pressure. It's important to make that distinction between a pump and a circulator, especially since we'll be discussing circulators that are used mainly in pressurized loop systems, systems like hydronic heating, radiant floor heating, or domestic hot water recirculation. Now, we're not talking about multi-stage, multi-impeller style well pumps designed to lift water a few hundred feet out of the ground. This is a distinction that makes a difference when sizing or selecting a circulator for your hydronic system, as we'll see later on. Okay, now that we're clear that pumps and circulators are different things, there are also several different types of circulators, each with its own design and best applications. Some are wet rotor, some are dry. These dry circulators are also referred to as close-coupled or three-piece circulators, by the way. Some need to be lubricated, others are self-lubricating. Some run fast, some run slow, while others can even vary their speed from fast to slow. In this course, however, we're going to focus on wet rotor circulators, and we'll use the TACO family of double O cartridge circulators as the great example of this type. Okay, it's time for a quick quiz. Now use the pause button down below me here if you want more time. When you're ready, click on the appropriate answer here over on the left-hand side of the screen. Are you ready? Let's go. Question number 1, true or false? The only purpose of a circulator in a hydronic system is to create flow. Question number 2, true or false? A circulator creates flow by using centrifugal force to create a pressure differential. All right. Question number 3, true or false? A pump and a circulator basically work in the same way, so they are interchangeable. All right, let's take a look at the answers. The answer to question number 1 is true. A circulator has one job and one job only in a hydronic system, and that's to create flow. The answer to question number 2 is also true. It's the centrifugal force created as the impeller flings the water towards the size of the volute that in turn creates the pressure differential we need to create flow in the system. And finally, question number 3, that one's false. A pump lifts water, a circulator creates a pressure differential, and therefore flow in a continuous loop system. The way each one works is different from the other, so they are not interchangeable. All right, good job. Are you ready to move on to the next lesson? Well, you can review this one by scrolling backward on the program bar down below. Otherwise, let's go to the next lesson.